Welcome everyone. This is the second lecture of the course, and I will start this lecture by installing another package. So the name of the package is plutostyles.jl, and we'll be installing this package from GitHub. And this will demonstrate that you can install package from other locations also. The packages that you install do not have to be registered with the Julia's own repository. So again, we'll start by running Julia, and it will take up some time to load. Then we'll go to the package environment and we'll check the status. And we will see that we have these three packages. So that means we are not in the correct environment. We will activate the correct environment and look at the status now. And you will see that the only package installed is Pluto, which we installed in the previous video. Now what we want to do is install this package, and we can do it just by using the command and followed by the link. And it will download all the codes from GitHub and install the package to our system. So this is an alternate method of using packages. You can just use the add command and then give the link of where the package is hosted. Okay, so this package is used for changing the styles of the Pluto notebooks. We have seen that the fonts of the Pluto notebooks by default were very small, and also the writing space was limited. So this package will rectify those. So to use this, it is saying that you have to use the command using Pluto styles and then run pluto.run. So we can do that here. So we have to go back to Julia. Okay, so before doing that, we can quickly check the status, and you'll see that we have Pluto as well as Pluto styles installed. So let me go back to Julia REPL using Pluto styles, and it will precompile some stuff, and then we'll use pluto.run, and we will pass the parameter launch browser equal to false, and this will give us the link. So let us open the Pluto notebook. Okay, so here this is again the previous thing that we have seen already. So we can open our previous notebook that we worked on in the previous lecture. This is the things that we learned in the previous class. We learned how to write commands, how to use the Julia prompt, how to use the Pluto notebook, and we ended after learning variables. So today we will start by learning about arrays, vectors, and matrices. So let me see when this notebook is completed loading. Okay, so everything is working properly. So we can go back, create a new notebook, save it as lecture 2, and we'll begin from there. Okay, so today we'll start by learning about arrays, vectors, and matrices. Okay, okay. So what is an array? An array is a list of different quantities. So we have seen how to define a tuple in the last lecture, and here this is very similar to tuple, but we can do much more things using arrays. So tuples are generally one-dimensional, and although you can create a tuple of tuples, but generally those are more better expressed in terms of arrays. So let us begin by seeing how to define an array in Julia. So we will again start by using the variable name, then within brackets we will specify elements separated by comma. So you will see this code will run, and this will store the value of 1 testing 2.0 in the variable array 1, and this is showing as any. So what is this any? So let us quickly look at that. So let us check the type of array 1, and you will see that this is the type is an of vector, and the vector can contain any element. So here any means the vector can contain any type of element. So the data type this array is holding can be of any type. And this vector is an alias for array any1. So what that means is 1D arrays are known as vectors. Okay, so can we define array in a different way where this any type will not be possible? We can also do that. Let us see how we can do this. So suppose we are just defining an array with 1, 2, 3 elements, and if you run it and check the type of array 2, you'll see that this is a vector which is taking int 64 elements. So again, this is an alias for array data type, and it is one dimensional, and the elements are of type int64. So we can also go to the live docs and search for array, and you will see that array is an n-dimensional dense array with elements of type T. So what it means by this array in curly braces int 64 and 1, you see that the first thing is the type. So int 64 is the data type of the elements, and n is the dimension. So this is consistent with what we are seeing here. We can also look at any. So you'll see that any is a data type, and any is the union of all data types. Okay, so every other data type will be a subset of any. So we can check that also. We know abstract data type number, which was the set of all numbers, and we will check whether number is a subset of any. We run and we'll see that this is true. So as it is described here, any is the union of all types. So Whenever you are unsure of what kind of data you will encounter in your code, you can use this any type. Okay, so that's how we can define an array. So far, using these commas, we are only defining 1D array. Now let us see how we can define a two-dimensional array. Okay, to define 2D arrays, we first need to understand how these commas, the semicolons, and the punctuations work in Julia when we're defining array. Okay, so let me create another section, punctuations for arrays. So the first thing is that when we are defining a one-dimensional array or vector, then we can use either comma or semicolon to separate the elements that will be stored in the array. So if we check, for example, let's make one ARR1, assign it a value 1, 2, 3 within braces, and run it, and you'll see that it has become an int64 1D array. If you check the type of ARR1, you'll see that it is indeed a 1D array or vector of int64 elements. Similarly, we can define it with semicolons also. And we can again check the type of it. And we'll see that again, this is a vector of int64 elements. And actually, these two arrays are equal. Now, if we want to add to another dimension, say when we are using comma or a semicolon, it is adding to the vertical dimension. So everything is in this vertical dimension. So if you want to add to another dimension, we either have to use space to add to horizontal direction. Alternatively, we can also use two semicolons. Okay, so when you are defining 1D array, we can use comma or a single semicolon. This will, again, let me clarify this. This will add the elements vertically. Okay, so let us see what will happen if you are adding the elements horizontally. Suppose we are creating another variable array3 and assigning it with the value 1 space 2 space 3. Remember, space will add the elements horizontally, and that means it will become a matrix, because when you are adding the elements horizontally, it is adding them to different columns. So again, we can check the type of ARR3, and you will see that this is a matrix, which is an alias for an array of dimension 2. So again, let me write it. Matrix represents 2D arrays. Okay. So similarly, we can also do this. Say the elements are 4, 5, and 6. You will see that the elements are now added horizontally. So again, this is a very, very crucial thing to understand. When we are defining arrays of dimension 1, we can use the comma or the single semicolon. That will add all the elements vertically. That means in different rows, and that will create a 1D array. And when you are trying to add the elements in different columns, that means we want to add the elements horizontally, we'll use a space or two semicolons. And this notation can be used together. So notation can be used together. So for example, let me define another array. Say we have the first element to be 1D array, which is again this 1, comma 2, comma 3. Remember, when we are using commas 1, comma 2, comma 3, then they will be added vertically. And if we take another array 4, comma 5, comma 6, again this will be added vertically. And these two elements are separated by a space. That means 1, comma 2, comma 3 and 4, comma 5, comma 6. These two vectors or 1D arrays will be added horizontally. So let us run this code and see the result. You can see that 1, comma 2, comma 3 is the first column, and the second column 4, 5, 6 is added horizontally to it. Now, here's another important thing. Suppose we want to add these two arrays 1, 2, 3, and 4, 5, 6. We have stored many 1D arrays here. We can also use these variables. So let us do with variables. So this here 1 is 1, 2, 3, and here 2. Let me make it 1, 5, 3 or 1, 5, 7. Okay. So we can use variables here also. And you will see that since we are separating them using a space, that means they will be added horizontally. And this will create a 3 cross 2 matrix. The first elements will be 1, 2, 3, which is coming from array 1, and the second column will be 1, 5, 7, which is coming from array 2. Now, what will happen if we write it like this? Those who are following the lecture, they can pause the video and try to guess an answer. If we run this code, you will see that we have obtained a vector with 6 elements. Let me confirm that by using the type of command, and you will see we have obtained a vector. So as we have already discussed, when we are using the semicolon, all the elements will be added vertically. So ARR1 was already a vertical array or vector or 1D array, and ARR2 was also a vector or 1D array. And when we are adding those two to a new array, we will get those two arrays concatenated vertically. So if that is the case, can you guys also guess the output of this? So will it be same as ARR6? Let's run it and check. To check whether these two are same, we can use the equality operator, and you will see that these two are not same. This is returning false. Why? We first can check the type of error 7, and you will see, in contrast to error 6, which was a vector of int64, error 7 is a vector of int64. That means this is an array of array, or in different languages, we can think of it as a list of list. So what is happening here? So the catch is that when we are concatenating arrays, then only semicolon will add them vertically after expanding. That means it will treat each of the element of the array as an element of the new array that is being constructed. So each element of the input array will be considered as an element of the new array. Okay, but when we are concatenating arrays and using the symbol comma, then that will treat the array itself as an element. So input array will be considered as an element itself. So when you're using the symbol comma, this will add the arrays vertically, but it will not expand them. So again, let us go over this concept carefully, because this is very important. In most of the numerical computation and linear algebra, those kind of problem solving sessions, we will be defining arrays, and it is very important to understand how we can create the arrays by hand and how the dimensionality and concatenation work. Okay, so again, let us start from the beginning. So let us say our first array is 1, 5, 3. This will be a vector. So we can also check the type of BR1, and this will be a vector. So we can use this single vector to concatenate itself to itself. For example, we can do BRR1, BRR1, and use the semicolon symbol to concatenate them. And remember, when you are using the semicolon, then all the elements which are 1, 5, and 3, they will be treated as separate elements for the new array. So when we run this, you will see that we are getting a vector which has 6 elements with 153 and 153 each being separate elements. Now let me save it to BR2 and quickly show you the type of BR2 is not defined because I have not saved it. Okay, so now it's visible. So I have also expanded the output prompt here. So you can see this is a 1D array. Now when we are doing BRR 1 and concatenating them using a comma, then you will see that each array becomes one element of the new vector. Okay, so the type of BRR3 will be an array of array or a vector of vector in 1D. So I hope using these 3 examples, this concatenation part and using the comma and semicolon operators to add differently the elements in vertical way, you have understood it completely. And if you still have questions, it is okay if you still have questions because this is very different from other programming languages. This is a very new way of defining and 2D arrays and concatenating arrays. So if you still have questions, please let me know in the comment section wherever you can ask questions to me. Please let me know. I will go over these things again. This is a very crucial part. Okay, and the first thing that we learned, let us define another array. Here are 4, and here we will be concatenating them using a space, and that will give you the array where both the arrays will be concatenated horizontally. Similar thing can also be done using 2 semicolons. Okay, you can again check that these two are same. Okay, so with this we can conclude the defining array section. So I will just conclude with a remark that the semicolon punctuation is universal. That means one semicolon will add elements to dimension 1, 2 semicolon will add elements to dimension 2. Similarly, 3 semicolons will add elements to dimension 3 and it will go on. So we can concatenate arrays in n dimensions using this semicolon notation. So you can see that this is also consistent with what we have observed so far. When you are using one single semicolon, this is appending vertically, that is dimension 1. When you are using 2 semicolon, this is appending horizontally, which is the dimension 2. So do remember this. And with that, let us go and check some other methods which you can use to define arrays. So let us now check some built-in methods of defining arrays. So let me quickly make another section. Okay. So the first method that I want to talk about is zeros. So you can again go to the live docs and it will show you that zeros is a function which create an array with an element type t and of all zeros with size specified by dims. So the first argument that this function takes is a type. If we don't specify it, it will take the float 64 type by default, and then it takes a tuple or a set of numbers, and that defines the dimension of the array that it will create. So let us say that let us not specify the type first. Let us say that the dimension will be 1, comma 6. And let us run this, and you will see that it has created a 1 cross 6 matrix, because 1 row and 6 column will be a matrix, and all the elements are of type float 64. Similarly, okay, and it is needless to explain that the function zeros will initialize an array with all the elements being 0. Similarly, we can check if we pass a data type, and if we pass 2 comma 3 as the dimension, then it will create a 2 cross 3 matrix where all the elements are zeros and the elements are of type int 8. We can write it like this also, where the dimension will not be passed as a tuple. So we can just write 2 comma 4, and that will also work. So this method is very handy when you want to initialize arrays with some standard values. It can be zeros or ones. And we can also pass 2 comma 2 comma 3, and it will result in a 3D array where all the elements are 0. And the size of the array is 2 comma 2 plus 2 plus 2. Okay. So there is another method which is similar to zeros, and that is ones. And again, you will see that this will create an array where all the element will be ones of, and the element data type will be t, which by default is float 64. And we can specify the dimensions also. So what will happen if we just pass ones? It will give a 0-dimensional array or just a simple number. So we can pass ones, we can pass the data type. Let's make it int 32 now. And then we can pass the dimension also. So we have passed 4 comma 2. That means it will create a 4 cross 2 matrix where all the elements of the matrix will be 1 and the data type will be int 32. This is very similar to zeros. And suppose you don't want to initialize all the elements to be 0 or 1, or rather you want to make an array with a different value, then you can use this fill command, and that takes this value thing first, value, then dimensions. So we can use this fill method and say we want the value to be 5.34, and then we want the dimension to be 2 cross 2. You can run this, and you will see that we have obtained the 2 cross 2 matrix where each of the values are a float 64 data type, and the numerical value is 5.34. So how do you change the data type here? There are several ways. We can define a function. We can define a variable. Say we make it float 32 and assign it a value 1.25. Then we use the fill command, pass the value x, and create a 2 cross 3 matrix. We will see that the matrix will have the value of x and the data type will be float 32. Similarly, we can make it int also, but you will see several errors because 1.25 is not a int. We can make it 7, and then it will work. Okay, so for the sake of completeness, I will just make it 7.0. And another way that you can use fill is like this. So when you are giving the value, say 16, you can say that generate a 2 cos 4 matrix where all the values are 16. It will by default take the int64 data type because the value we have passed is by default taking the int64 data type. So what we can do is we can type int 16 here, and that will make the value int16 type. And if we run it, we will see that the matrix will also have elements with int16 types. So these are some ways, built-in functions that we can use to create arrays readily. Now, suppose we are creating arrays by hand, like here, and here we want to change the data type. And you will see that everywhere where we have not specified the data types, it has either become int64 or float64. So let us see how we can do that. So suppose our array is ARR8. I am getting out of numbers. So I forgot what the last ARR value was. Yes, it was ARR7. So now it is ARR8, the variable name, and our values are given like this. So this is a quick question. Will this work? You can pause and ask yourself. I will just run it and it will give this syntax error. What is the error? We have forgotten to define these two as arrays. Okay, now we can see that it is working and it has created a 2 cross 2 matrix. Now, all the elements here are in 64. Suppose we want to make them int 128. We can do this by writing the type just before defining the array. So, if we do that, so here let me cut it and do it on a different variable. And you will see now the matrix will have elements of int 128 data type. Okay, so now let us do a real-time problem. So let us say that we want to make this kind of array. So 0, 0, 1, 0, 0, 2, 3, 4, 5. So if we run it, you will see that this will be a 3 cross 2 matrix where the elements are defined like this. So we already know that we can use the zeros function. Okay, so to make it intuitive, we can use this also. We can make it like this. So we already know zeros and one functions can create arrays where all the elements are in zeros and ones. So can we use those functions and this technique of using multiple semicolons to concatenate them to generate this array in a different way? So let us see what we can do. So first thing we'll be having a zeros and we will have 2 comma 2, but since the elements are in 64, we have to make them int 64. Okay, now we are appending 1 and 1 after the zeros and zeros horizontally. So we'll use a space and we'll use ones. Again, we'll use the int 64 data type, and here we will have two elements. So if we create an array like this, you will see that we have created the top part. Now, if you want to add the bottom part, how can we do that? We can use a semicolon that will append vertically, and we can just write the elements here. So Here the bottom elements are horizontally arranged, so we have to use the space. Use just space or just semicolons, you will see that this array that is being generated is same as the array that we wanted to generate. And we can just check with an equality whether this is same, and you will see that this is returning true. Okay, so now with that, let us move on to the next section where we will see basic functions that one can use on these arrays. So let me quickly make a new section. The first thing is what is the dimension of the array. Another thing that one might want to know is what is the length of the array. So dimension and length are somehow different. So they might also want to know what are the element type of the array. And in order to get these answers, there are some functions in Julia that are built in which we can use. Okay, so let us take this ARR10 variable where we have stored this matrix, which is a 2D array, and run the functions and check all the available functions on this array. Okay, so the first function is size. So what will happen if we run it? We can check it using the live doc, and you will see that size is a function which take an abstract array. So this size function will return a tuple containing the dimensions of A. So this size will give us the dimension of A, and the result will be a tuple. So we can check the type of this, and you will see that this is a tuple of int64. So let me quickly remove the tuple part, sorry, the type of part, and you can see that it is returning 3 comma 3. That means the dimension of ARR10 is 3 cross 3. That is correct. Let us again check with another array, for example with this BRR5, which was a 3 cross 2 matrix. And you will see that it is returning 3 comma 2. Now there's another function called length that will return the number of element in a collection. So what is a collection? Collection is a different kind of data type. We'll talk about them later in this video or in the next video when we are discussing loops. Okay. So if we use the function length on the variable br5 and run it, you will see that it will give you the value 6. Similarly, on br10, it will give you the value 9. So what length is doing is it is just counting how many elements are there on the array. So size will give you the dimensions. If it is an n-dimensional array, it will give you a tuple which contains n numbers, and what length will give you is the product of all those numbers. Okay, there is another command or function called ltype. So what this ltype function will do is give you the type of the elements that is stored in an array. So if we pass ARR10, you'll see that it will show you in 64. So to get a different result, we can pass zeros array. And remember, by default, it takes float 64 elements. And if we run the ltype command on it, we'll see that it is giving you the result float 64. And I forgot to mention one thing when I was discussing size, that is, you can pass the dimension along which you want to get the size of an array. So if we pass BRR comma 1 to size, it will give you 3. If we pass BRR 5 comma 2, that will give you 2. So that can also be done. And there's a similar command which does a similar thing in dims, that will just give you how many dimensions are there in this array. So it is a 2D array, that's why it is returning 2. If you change it to point to the error 10, then also it will give you the answer 2, because that is also a 2D array. Now let us look at some other functions which we can do on these arrays. So before looking at this, let us check how we can access the elements of these arrays. Okay, so let us quickly show what the values of the error 10 array is. So suppose you want to get this element which is on the second row and second column. How can we do it? We can pass a 2 comma 2 parameter within third braces. So what it is doing is that the first two here is referencing in second row, and the second two here is saying that look at the second column. So first two here is pointing to the second row, which is dimension 1, and second two is pointing to the second column, which is dimension 2. So if you want to get access to the element 3, what can we do? We can check that this is in the third row and on the first column. If we run error 10 within third bracket 3 comma 1, it will give you the element at that location, which is 3. So again, remember that array indexing starts from 1. So we have seen this in the previous video where we are getting the elements from a tuple, that the indexing starts from 1, and this is again the case for arrays also. Now let us look at another function, which is cat. This is again for concatenate the input arrays along a dimension. So we have seen how to do concatenation using one semicolons or two semicolons, but there is a dedicated function, and this will be very useful when we are using high dimensional array, say 10 dimensional array, and in that case, using these functions can be more intuitive than using the semicolon method. So we can generate again some new array, say 1 comma 2 comma 3. This will be a vector, and we can use the cat command and say, let's look at the live doc here, that it is taking an array A, and then it is taking a parameter called beams. So A is a list or array of the arrays that has to be concatenated, and beams is the dimension where in which dimension this will be concatenated. So suppose we are concatenating the array CRR, and let's take another array from the beginning. which is say BRR1. So let's make this CRR1. So CRR1 and BRR1, and the dimension will be 1. Okay. So it is giving an error saying that the keyword argument dims is not assigned. That is happening because we have, since this is a keyword argument, we have to write dims equal to 1. Again, this is important part, which will be discussed when discussing functions. So there are basically two kind of arguments. One is the positional one and another is the keyword one. So all the keyword arguments you have to specify by writing the name of the argument. And you can see that the array CRR1 and BRR1, which was 123 and 153, has been concatenated in the first dimension. What was the first dimension? It was the vertical dimension, and you can see that it has been concatenated. Similarly, if we concatenate them in dimension 2, you will get a matrix where these two arrays are added horizontally. So there are some other helper functions also, hcat, which is equivalent to cat with genes 1. So let us check that. So hcat stands for horizontal concatenation, and you will see that it is giving the same result as this one. Similarly, there is another function vcat, which is equivalent to cat with dimension 1. And you will see that this is giving the same result and as this one. Okay, so this is another function. Now another thing you might want to do with matrices is transpose them, and Julia has a nice syntax of transposing matrix. So you can either use the function transpose, and that takes an array or a 2D array, and that will transpose it. So you can, if I can spell it correctly, you will see that transposing this array, it has become 003, 004, and 115. So it has transposed the array correctly. Or we can also use this symbol. We can write the array in the variable where the array is stored and follow it using a single quotation. So this is how we write transpose in symbolic math also. So the same syntax works here. So you can do these things also. Say this is one array, and what mistake have I made? Yeah. So this is a 2D array where the elements are 0, 1, 0, 0, 1. So this is a 2 cross 2 identity matrix, and we can just use the single quotation mark after we are defining, just typing the matrix, and we can run it, and you will see that it has transposed. So this is a very bad example. So make it 1, 2, and you will see that the transpose is working. Okay, so now let us see some other functions. Say, let us see how to define random arrays. We can define random arrays using the rand function, and this like doc says that function picks a random element or array of the set values specified by s, and it is indexable collection. So basically this will give you a random array. So we can type 1 comma 2 rand 1 comma 2, and this will give a 1 cos 2 matrix of random arrays. So we can make it 1 comma 100, or sorry, we can make it 100 comma 1. That will give you a vector. So this is all the values that has been generated is uniformly distributed between 0 and 1. Similarly, we can also use the randan command, and here the random numbers that has been generated will be normally distributed with a standard deviation of 1, and mean will be 0. Okay, so when we learn about plotting in a different lecture, we will be checking whether these properties are true or not. Okay, so the final function that we want to talk about is reshape. So this is another very important function. So suppose you want to change the shape of your array. Suppose we have a vector or 1D array of 9 elements and we want to make it a 3 cross 3 array. So that is a nice pattern. And when you have that kind of pattern, you can use the reshape command, which will reshape your given array into a different size. So by size, I mean this dimension that is obtainable using the size command. Okay, so let us check. So our ARR10 array was this. If we reshape it, we'll pass the array which we have to reshape, and say we want to reshape it as 1 comma 9, and you will see that the matrix has been reshaped in such a way that the elements are now forming a 1 cross 9 matrix. We can similarly do 9 comma 1, and that will give you a 1D vector. When you see this result, you will see that this is reshaping first along the lower dimension first. So this vertical dimension, which is different rows, is the dimension 1. So it will first take out those elements vertically, then it will go to another dimension and then take out vertically, and then it will do the last column. So 003, 004, 115. Suppose you want to do it like this in the opposite way, 001, 001, 345. How can one do that? Very simple. We have already seen it. We can just transpose the matrix. And you'll see that we'll get 001, 001, and 345. So with that, I think we are almost finished on learning about arrays. In Julia, we mainly learned how to define arrays and what are vectors and matrices. These are 1D and 2D array, how to define the data types of array, how to concatenate array using different punctuations. And we have also seen some functions which can generate some arrays of given data type and given shape and fill them with a desired value. Also, we have also seen some functions which work on arrays. For example, the size function, index function, length function. We have also seen how to access the elements of the array, and we have seen this vcat, hcat, those concatenation function which works very similarly to the semicolon, comma, and space punctuations technique. So we can concatenate array using these functions also. Then we have seen also how to define random arrays and how to reshape arrays. I will end this section with a simple comment that arrays are mutable. What does that mean? That means that error 10, which was having this value, we can change its value after we have defined it. So we have to make it 99. So we can see that we have changed the value of the array. You can run it. You can run it. See that the value of the array has changed at the 1, comma 1 index. Although arrays are mutable, we can change the values of the different elements. But again, this is not recommended because you can see that when you are changing the values like this, the other places where array 10 has been referenced, those values are not getting changed automatically. Here we have to run every cell manually and then only it will change. So this is one caveat, but still it is a possibility to change the particular elements of an array after it has already been defined. So arrays are mutable in contrast to tuples which are immutable. Okay. So now let us move on to the next section. So now that we have learned about arrays, let us go to the next section where we will be learning about conditional statements. If you are familiar with any programming language, you will see that often in the syntax there is written something like if, else, with this kind of keywords. So these are conditional statements. They are also known as if-else statements, and these are a fundamental programming construct that allow the user to control the flow of the execution of the code that one has written. So when you use these constructs, this enable us to make decisions and execute different code blocks depending on whether a condition is true or false. So as you can understand just by the definition, these are very crucial for creating a dynamic and flexible software. So suppose I will give you an example. This is very similar to our logical thinking also. So if you are deciding whether to take an umbrella out today or not, so what we will do, you will check the weather, you will see if it is going to rain, then you will take the umbrella. If it is not raining, you might also want to check whether it is going to be very hot. Then also you might want to take the umbrella. If none of the above, then you will keep the umbrella in your room. So we think like this, but programs they cannot think like this. So we have to dictate and spell it out for them. So that's why these conditional statements are designed. Okay. So I hope I have given you a rough idea of how these conditional statements work and why they are useful. So let me quickly give you the syntax of conditional statements in Julia, and then we will solve two problems and we will see whether these statements are working correctly, and then we'll move on to the next section. Okay, so in Julia, conditional statements are written with the if, else if, else, and end keyword. So these are keywords for conditional statements. So how do you write it? What's the syntax? So you start with if and you give it a condition. Say it is condition 1. So we have seen in the previous class and some examples in today's class also, that we can compare two things, two variables, one value and a variable, and we can get answer in true or false. So these conditions have to be things which will return you a bool data type, so that the program can understand whether what you are evaluating is true or false. So then you can do something when this condition 1 is true. If that is not true, then you can write another condition, say condition 2, with the else if keyword. And after you have written that, whatever code you write after the else if command, it will run only if the else if command is true. And similarly, if that is also not true, you can write multiple else if commands also. So here you can write as many as else if commands as you like. Okay. So the only catch is that it will start executing from the top, and once a condition is being satisfied, it will not run anything else. So you have to keep in mind that the conditions, when you are writing them, you have to order them in such a way that you are not creating a flaw in your programming logic. Okay. So if condition 1 is satisfied, condition 2, 3 will never get run. Even it will not get checked. Similarly, if condition 1 is false, then only condition 2 will check, and if it is true, then condition 3 will never get run. So that's how this logic works. And if nothing is true, then you can do something, and that you can specify after writing the else keyword. And remember this carefully. Whenever you have finished writing all of your conditional statements, you can write an end keyword which will indicate that your code block, which was dealing with the conditional statements, have ended here. So it is crucial to write this end statement, otherwise it will give you a syntax error and your program will not learn. Okay. So with that, let us see how we can use this in a problem. So suppose the problem is print a number if it is divisible by 10. If not, check if it is divisible by 5 and print the square of that number. If none is true, print a sad emoji. Okay, so we have learned about this conditional statement, so we can easily tackle this. So how can we do that? Let us define the variable number first, and let us say that it is 10. So the first condition is to check whether the number is divisible by 10. How can you do that? We'll use the if keyword, and divisibility is checked by using the modulo operator. We have seen it in the previous class. We can say this, which will take the number and get the remainder of that number when it is being divided by 10. And if that is equal to 0, again double equal is here the comparison parameter, and this is actually generating the true or false value. So it will check whether the remainder is 0. If it is 0, then that means it is divisible by 10. So here we have to print the number. So you can print the number. Then if it is not true, what we are required to check that whether it is divisible by 5. So again, we can do it similarly. And then we are required to print the square of that number. We can do square using this caret symbol. And if nothing is true, we have to print a sad emoji. So Julia supports printing these Unicode characters and emoji. Let me check whether I can find that. Uh, so the way you find emojis and these Unicode characters, you type the backslash and then you write the name of that emoji. So if you type haha, and it should give you the okay, the name is different, so you have to know the name actually. So let me quickly check a few things that comes to my mind. Okay, so we have this disappointed emoji. We can use that. So it will print the disappointed emoji if none of the conditions are true. So let us run this command, and you will see that it has given you a syntax error. What is the error? It is saying that it has expected a end keyword. And remember, I was talking about that if you do not give this end keyword, it will show you an syntax error. Now that we have applied the end keyword, we can run it. And again, we are given with another error message. And this is particular to the Pluto notebooks feature. So what we can do is we can avoid doing multiple statements in the same block. So this here is considered a statement, and whole of this if and block is considered a statement. So if we save it, you will see that now it will run. So what I've done is just we have defined the number at a separate location, and we have performed all the if else job at a different location. So it is working correctly. As you can see, the number is divisible by 10. That's why it is printing 10. Suppose the number is 15, then it will not be divisible by 10, but it will be divisible by 5, and then it will print the square of the number, which is 225. And what if we make the number 151? Then it is neither divisible by 10 nor divisible by 5. That's why it is printing this emoji. Okay, so that's how the if else statement work. And I will quickly show you another method, which is nested conditional statements. That means you can chain these if else statements one after another, and depending on true or something in the if or the else if block is true, then only the next if block or else block will work. Okay, so that structure is called nesting, and we'll see how the same problem can be executed with the help of nesting. Okay, so let me just quickly copy and paste everything so that it is a bit easier. So first we are checking if the number is divisible by 10. Then we want to print the number. Then if it is not divisible by 10, then we can delete this part. Then what we have written inside the else if command, we can write it under the else block also with a separate if command. Okay. So here we can supply the next condition that if this is not true, so if this condition is showing false, then this the code under this else block will run, and the code under this else block will again check if the number is divisible by 5. And then I want to print the number square. Now, if that is also not true, then we can use another else statement, and then we'll print the sad emoji. And again, if we are using if command, we have to end it. So the number of ends will be equal to the number of ifs that you have used. Okay. So these two programs, although they achieve the same thing, they are structurally a bit different. So here, this is a nested if else block. So this part will execute only when this if command is not true. So let us run it and check. So what I will do is I will change this number and save the notebook, and the results in both these blocks will be updated at the same time, and we get to see whether these are same or not. If these are same, then the code is working as expected. So 10, they are giving the correct result and both are same. 20, they are giving the correct result, both are same. 21, you can see they are again giving the correct result and both are same. Let us do 150. This is again correct. Let us do 5. This is again correct. So that's how you use conditional statements in any programming language, and we have today learned the syntax of how to use conditional statements in Julia. You will see that this comes handy when we will be tackling more difficult problems. Okay, so with that, let us move on to the next section. In this section, we'll look at how to do array operations. So mainly we'll be looking at how to do addition to arrays, subtraction, array multiplication, those things. So let us define a section. As array operations. Okay. And we'll learn here about the dot syntax. So this is again another important thing that you want to know when we're using Julia. Okay, so let us start by using an array or defining an array. So let it be 1, 2, and 3, 4. So this will be our array 1, 2, 3, 4. Or we can do it like this also. Yeah, so 1, 2, 3, 4. So this is our array. We will not be checking the types and those things now, since you are pretty familiar with that already. So now, suppose you want to add this array with another array. So let us define another array. Say this array is ones and the size is 2 cos 2. Now, suppose you want to add A with B. What you can do is use the plus symbol. So you can write A plus B, and if you run it, you will get the answer. Now, two things are happening here. Again, you will see that the first array that we have defined is containing the elements of int64 data type, and the second matrix is containing the element of float64 data type. Okay, so here when you are adding, this is doing the array addition perfectly, but it is promoting everything to the float 64 data type. So we have seen this structure a couple of times now, that when you are adding something integer and a float, it will become a float. If you are adding an integer in 16 and in 32, it will choose one of the data types. So how do we know what data type it will choose? So there is another function that we can use. So before using that, let us check this. So int 8, 10 and int 32, 122. If we add these two, you will get the correct answer. And if we check the type, we see that it has promoted to the larger type. So there is a function in Julia called promote, where you can pass these operands as arguments. So say these and these, and this will give you the same things that you have passed to it, but it will make sure that all the data types are same. So what the data type will be of this promote result, that same data type will be used by these functions also. So if you want to check, you'll see that we have passed. So let me check that also. I typed it wrong. We don't have to use a copy. Okay. Yeah. So when we are checking the data types of this, it is saying that it is an int 8 and int 32. And if you use the promote function, it will promote everything to a common data type. So if you are using int 32 and int 8, it will be promoting all the values to int 32. Similarly, we can also check with integers and floats, and you'll see that it has converted the first integer to float. So whenever you are unsure that if you are adding a integer with float and a float with a bool, you can check after the addition what data type will be used using the promote function. So now we can see that since integer and a float, when they are used in this kind of operation, the integer will be promoted to the float so that both of the data types matches. And then we see this result that here also the same thing is happening. So it was int in one matrix and float in one matrix. So when you added them, it has become a matrix where the data types are float. So this uses the promote function under the hood. Okay, now we have seen how to do addition. Now let us see how to do subtraction. So you can see again, this is using a common float 64 data type, and it has subtracted one from every element. Now let us define another array. Say 0, 1, 1, 0. So this is again a true cross true matrix. And when I say array, I am referring to the general case. A matrix is also an array, a vector is also an array, just it's the dimension that is being fixed. So yeah, so this is our C. So what will happen if we do A star C? you can see that our A was 1, 2, 3, 4. And if you are multiplying this with C, which is with matrix 0, 1, 1, 0, you are getting this result. So what it is doing under the hood is it is performing array multiplication. So that means A and C are in general can be different. So A and C are multiplied here with the rules of array multiplication. And in general, A star C and C star A is different. And if you do this, you can see that the result will also be different. Now, since this is doing array multiplication, what happens if we want to check whether we can multiply the arrays element wise? So suppose our array is 0, 1, 1, 0 and 1, 2, 2, 3 like we have defined. So let me quickly show the value of A here also. So yeah, these are the arrays that we have defined. Suppose we want to multiply two arrays in such a way that one element of these two arrays get multiplied, then two element of these two arrays get multiplied, then one element of these two arrays will get multiplied, and the result will be an element-wise operation. So you can also do that using the dot syntax. So whenever you are writing, okay, just let me annotate it first. So whenever you are writing just star, you are implying that it will do array multiplication, and when you are writing dot star, that means it will do element-wise operation. So you can see that it has done element-wise operation, and the places where we had 0 are now 0 in the new array also. So we can again check with C dot star A. Since these are doing element-wise operation, this all should be same, and you can see that these are same. We can even check like this. And you will see that this is true. And this is false. Okay. So another thing one can check is whether arrays of different dimension can get multiplied. So let me define two arrays. One will be made of all, okay, all zeros will not work, all ones, and say the size will be 2, 3. So this is one of my matrix, and let me define another matrix by hand, say E. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be a 3 cross 3 matrix. Now, what will happen if we write D star E? It will give me a 2 cross 3 matrix, because 2 cross 3 matrix multiplied by 3 cross 3 matrix will result in a, so these two dimensions have to be same in matrix multiplication. We know this will result in a 2 cross 3 matrix. Okay, so this is correct. But if you want to run E star D, you will see that it will give you an error. And This will be an error from linear algebra. This is another inbuilt package in Julia, which is saying that the dimension mismatch has happened. Matrix A has 3 cross 3 dimension and matrix B has 2 cross 3 dimension and they cannot be multiplied. So you can see that the array or matrices, when they are getting multiplied, they follow the dimensionality rules of matrix multiplication. So dimensionality shape of matrix multiplication applies here also. So I have removed it. So let me just put it as a comment that this will not work. Okay. Now, another thing we have to keep in mind that when we are doing element-wise operation, then also the size of the matrices has to be exactly same. So when you are doing matrix multiplication, only the last and the first element of the order has to be equal. Then you can do matrix multiplication. But when you are doing element-wise operation, it has to match the dimension in every direction. Okay. So let us check with 2 cos 2 zeros and 2 cos 2 ones. And you will see that it is working. But okay, so let me make a new cell. Yeah. Even if we make it like this, where matrix multiplication will be possible because the trailing dimension of the first matrix is same as the first dimension of the second matrix, this will not work for element-wise operation. And this is happening because again dimension mismatch is happening. So here this is possible and everything will be zero. This will be a 3 cross 4 matrix. So I hope we have understood how to do these matrix operations and how to do element-wise operation on matrix. Another cool thing I want to discuss is why this element-wise operation is needed. So you can think the very useful use case of vector dot products. Suppose you have a vector in 3D coordinate system and the vector v1 is given as 1 to 3. That means 1 I cap plus 2j cap plus 3k cap, and let us define the vector v2 as 0, 1, 1. So this will be just j cap plus k cap. So if you want to do vector dot product, which is simply given by this formula, So dot product will be given by this simple formula for 3 dimension. For 2 dimension, this will be 2. That here we are doing element-wise multiplication. So the dot product of V1 and V2, we can get this just by writing dot star V1, V2. And you will see that it is giving you an array because it is not doing the summation part. We can do that just by writing sum. And when you write sum, it will sum over all the elements of the array. So you can see that this is a simple uh, implementation of the dot product. Okay, so this is one case where this element-wise operation will be useful, and there are many such use cases. So since I have introduced you to the sum function, let me introduce to the sum or cumulative sum function. Again, we can go to the doc and you see that what it is doing is cumulative sum along the dimension of dims. So also you can use this exclamation mark to use a pre-allocated output array, but we have not talked about this syntax yet. So we'll skip it for now and see how this sum function is working. So let me quickly minimize the live docs and define array, say by y. And we'll make it a simple array of dimension 3 cross 3, and let's make it int 8. So this is a 3 cross 3 matrix now. Now, if you do sum and pass the array y, you'll get an error because what this will do is this will do cumulative sums, but we have not specified which direction to use. So what to do? We can specify the dims keyword argument. Say we want to do the sum at the direction 1, which is the vertical direction. So if we do that, you can see that each column has been replaced with the cumulative sum of that column. So you can read it like this. So here it is 1 and 1. The second element will be the summation of all the previous elements. So the third element will be the summation of this and all the previous elements. So here this is 1. So this will be, after the constant, this will be 1 plus another 1. Here this is again 1. So after the sum, this will be 1 plus 1 plus 1, 3. Similarly, you can do this cumulative summation in another direction, and you will see that it will do the cumulative summation along this. So this is again very useful when you want to do rolling average and those things. So we'll talk about that probably when we are solving a relevant problem. Okay, so now let us check what will happen if we are using this commission function on a 1D array or a vector. Okay. You see that here you do not have to specify the dims, the dimension. Where again, this is an example of multiple dispatch. So depending on what kind of input we have given, so here we have given a 2D array or a matrix, and here we have given a vector or 1D array. Depending on what kind of input you have given, the programming language can make a decision of which version to use. So this, if you just type the name of the function and press enter, you will see a message that this function is a generic function that has 3 methods. So one function name is associated with 3 methods. And when we are passing the argument, which is a 1D array, one of the method will get executed. Similarly, when we are passing a matrix, another method will get executed. So this is an example of multiple dispatch, and we'll learn about it more in one of the videos, maybe the video after this one or the fourth or fifth lecture. Okay. So this was just to show you that sometimes Julia will have multiple methods for a particular function name, and depending on what kind of input you are giving, it will choose the correct method for that kind of input. So here, when you are passing a 1D array, you do not need to specify the dimension because 1D array has only one dimension, and that's why it is doing this cumulative sum simply just along this direction. But when you are passing in 2D or 3D array, then you need to specify the direction, and then it will ask you to specify that which direction you want to sum. So let us quickly check that whether this result is correct. So the second element here was 2. So after cumulative sum, it will be 2 plus 1. So this is 3. This is correct. The third element here was 3. So after the cumulative sum, it will be 3 plus 2 plus 1. So it will be 6. It is correct. The next element is 0. So nothing will be added. So it will again be 6. Then it is 4. Then so it will be 4 plus 3 plus 2 plus 1. So this will be 10. Again, this is correct. Then 15, 21. So this is all correct. So that's how you do cumulative sums on arrays. I think that we are pretty close to the 2 hour mark. So I can stop this lecture here and we can recap what we have learned so far. So I plan to do these recaps at the end of every lecture so that you can remember all the things, all the things that we have talked about, because these are anyway pretty long lectures. So you might forget what we are learning in between. So what we have done so far, we have, let me just follow the style that we used for the first lecture. So what have we learned? And we'll also make a section on what we learned in the next video. Okay, so today we have learned how to define arrays in Julia. We have learned about dimensions of arrays. 1D array is known as vector. 2D array is known as matrix. We have also learned about array functions like size, length, and dims. We have learned how to concat multiple arrays using the cat, vcat, hcat, these functions, as well as with the colon, double colon, comma, space, this symbols. Okay, we have learned about array arithmetic. We have learned about array element-wise operations. We have learned about methods to readily generate arrays. The methods are zeros, ones, fill. We have seen two methods, sum and cumulative sum, which we can apply on arrays. Then we have learned about conditional statements. We have learned about nested conditional statements. So these are if, else commands, and these are if, else, then followed by and if, else, end command. So here one thing I will mention that it is not necessary to write else or else if always. Okay, you can just write if and end. So let me quickly show you that. So if 10 is divisible by 5, print yes, end. So this will work. And suppose we are doing this, then this will just not print anything. So this is not necessary to put the else if or else command if your code doesn't have any logic for that. Okay, but you can anyway put for your logging and those kind of stuff. Okay, so we have solved two basic, not two, one basic problem where these conditional statements are used. So let me check if I've missed anything. Okay, so one thing that I have missed is the random arrays using rand and randn functions. And another thing I missed is fixing data types in arrays. We have learned the use of promote function also, which can help you understand when you have two different data types and you are doing operations with them, what will the resulting data type be? So yeah, so that's all we have learned today. I hope that you have liked today's lecture, and in the next class, we will start by looking at iterative statements or loops. We'll do problem solving, and these will be serious ones, which will use the concepts of both conditional and as well as iterative statements. And I think that will take most of the time of yes next lecture, but today also I wanted to go through the features of Pluto again, because in the last video I was checking that all the features were discussed at different points. So this is kind of scattered now. But since we will be using Pluto throughout this course, I think it will be beneficial if I put all the features and the caveats of using Pluto at one place. So I want to do that at the end of next lecture. So that is our goal. So with that, I would like to thank you all for sticking to the end of the lecture, and we'll see you in the next class.